In this third and final video, we're going to look at what we can do with the results that are generated from the study, as well as how we could then present these results and create a report from it. Let's jump back into Fusion and gain an understanding of what the FEA is telling us. Once the study has finished solving, you can just click on Simulation Results up near the top right. Straight away, looking at this, even if you've never run one of these studies before, I'm sure your brain is already telling you that red is likely to be bad and green is likely to be good, and yellow is bound to be somewhere in the middle. And your brain will be telling you correctly. So just to give a bit more information about this, generally the study is going to color code it, and as we've already realized, red generally means it's fallen below a certain category or it's at the lower end of the spectrum. Yellow is in the middle. Green is what's really good, and blue is when it's really high up the scale. Now, this can be either seen as really good or not quite as good as you'd like it to be, depending on how you're looking at the part and the functionality of it. So blue is sometimes referred to as the term over-engineered. Now this means it is withstanding well above and beyond what you'd expect it to be able to withstand. Now, for some products, this may be a good thing, but for others, this may mean that you're using far too much material and you could save on the money from that. You could be a bit more environmentally friendly if you use less material, or you could reduce some of the mass by removing that material as well, which may therefore, depending on what it is, increase the performance of that part in other ways. So just to look at this in some different scopes, what we can do is we can move from load case 1. What we could do is we could rerun this same study on this part with different forces, and we can compare each of those loads and view them separately. What we can also do here is look at the dial and sort of see where certain parts place within that. We can also change what it is that we're actually analysing it for. So if we start to look at displacement, this is how far the part moves away from that original position. Again, within each one, we can also start to look at it on a different axis. We can also change the units that we're actually looking at this in. And within the dial, it's also going to change us what our minimum is. So we've got no displacement right near our structural constraint, which is expected because we've told Fusion that that part of our design can't move. As we move through, you can slowly start to see that it moves and it displaces just under 2000 millimeters. Again, that's just because I put that ridiculous load in of 50 million newtons. Generally, we'd not expect a part like this to displace quite that much. So what I'm going to do, I'm going to go back and change this to stress. And what we start to see is that most of our stress is happening near our structural constraints, as that can't do the displacement, which takes away some of that stress. Again, we can look at those based on different areas, as well as changing our units. Really good one to be aware of when we're looking at displacement, and we change this just so we're looking at it from the side perspective, is that quite often the default on Fusion is underneath this deformation. And what it can quite often do is it can be set to adjusted times 2. And what's going to happen is you might load your FEA study and it looks like what would expect to be a I-beam staying where it is, looks more like some sort of bending banana. So what you can actually set it to is what's known as actual, and that will show the actual amount of displacement that's happening in your model. If, like, for whatever reason in our model, you can start to go lower than the actual displacement itself. Again, you can also go even further if it is a model that barely displaces and you just want to see, and you just want to exaggerate that displacement just so you can see where it is that it's taking place. You can do that just from this menu. I'm going to leave it at ×1. What I'm going to do now is look at some of the other tools which allow us to see the results in more detail. One of the features that I really like from this results section is if you go to results tools, we can actually select animate. Now what this will do is we can use this dialog box and we can actually put in how many steps. So how much does it fraction this out? So for example, if I select 20 and I click on play, it's going to gradually increase that load, going up in fractions of 20ths. Again, if you want to show more detail, you can add more steps to this, and it's going to show it in a more gradual way. So I'm just going to stick with 20 for now. What you can do, which is often quite important, is we can actually start to put some of this information into reports to present it either to other people or just to keep a log of these studies for ourselves. We can actually click on the record button and we can actually publish this both to the cloud and to save that video within our computer as well, just by clicking on save. The next one, moving along the top, is compare. And if we ran multiple studies, this just allows us to compare one result to another. This becomes really useful when we are doing our material choices for the part. And we've got a final design, but we're just not quite sure which material to use just yet. If we then move over, we can go to inspect. What this allows us to do is show our minimum and maximum point for whatever it is that we're looking at. And we can also place probes on our design. So what this does, it literally just drops a point on the design and tells us exactly what the result value is for that area. Can select between surface probes and just probes within a 3D space. So for now, I'm just going to drop a couple of surface probes. So it might be that there's a particular point of interest on my design, and I can just click on that, and it's going to show me the displacement, or whatever it is that I'm actually looking at on that design. Once you've added those probes, you can click on OK, and it will leave those there for you. Another really cool feature under the Inspect menu is this Create Slice Plane. So this is similar to adding a section view. Simply click on the face or the profile, and we can drag this through our design, and we can actually look at it internally, how it's affecting the part as well. You can set it to display that in a different way with these 4 options. Once you're happy with it, simply click on OK. If for whatever reason you are finished with looking at that slice plane, use your browser and you can just start to hide these different options. Once you're done with running through and analysing it in those different ways, something that you can do to finish off, which is becoming increasingly important in today's world, is being able to present data in a helpful way. To do this, I would recommend going to the results tools once again and selecting report. Again, you can change some of the information such as the file type, who it is that's created it. Once you're done, click on save report, or you can just click on preview. It's going to give you an idea of what this report will look like. So just to give you an idea, this is the preview of my one. It's going to give us some information about the properties of the study itself, how it is that I've set it up, some of the key material properties, some of the loads that I've added to this study. And then it's going to give us some information about each of those key ways of identifying how the part has coped under those stresses. Hopefully these videos have taught you the fundamentals of what FEA is, how to set up a study, and then to analyse the results that it gives us. So on behalf of CAD/CAM Educators Hub, thanks for the support and see you on the next series of videos.